CNT120, Chapter 2. Our next stop is in our closet. We just got done talking about our patch panels and, patch panels and punch downs and so forth in the closet. And they're saying, hey, there's some other equipment that might be in the closet, things like some voice over IP equipment. And they also mentioned two other terms while we're here. So real quickly, voice over IP equipment, IP telephony. You might actually have some IP phone equipment in the closet in the form of switches that would power your IP phones. If I take a look here, I think this is the picture they use. Yeah. Your old school legacy PBX, private branch exchange, the phones kind of like hardwired into it, and this was literally a phone switch. And this, if it, manufacturer A, this company like ROM, that switch had ROM phones using their cable infrastructure connected all together, and that switch handled the phone calls and routed it out to the phone company outside, if you will. Modern day, you typically have IP phones that plug into switches. Well, those switches, I think I have it down here. Yeah, these switches need to power those phones over what's called power over Ethernet. You send power across the unused data wires to power the IP phones. So the phones are actually going to power, the phones are going to get their power from the switch. So one of the things that might be in the closet are switches to power these phones. Another thing that might be in the closet is that phone server, if you will, a phone or voice over IP PBX, private branch exchange. You could think of this as like a phone server. It's designed to handle the phone traffic that comes to it and route it to the other phone to make the phone call, or route it outside to a phone provider that will route the phone call to another company, cell phone, etc., etc. Okay, so you could think of this almost as a phone server that handles that phone traffic. You're typically going to run into the SIP protocol, Session Initiation Protocol. This protocol is the one that gets used to handle the setup of this phone call. When I start dialing digits, it's SIP traffic moving to the phone server. The phone server routes the call. Once both phones pick up, if you will, then another protocol kicks in to carry the data. Typically RTP, Real-Time Transport Protocol. But SIP is the protocol that tends to get used for the setup on these phone calls. So that's why they mentioned that in this part of the chapter as well. So in my work area, I would have probably IP phones. They're going to be connected into the infrastructure back to the closet. Here's a typical IP phone that would be on a desk. On the back, I literally see this is a network card. That's a NIC for that phone to plug directly into the network. And it would be connected into the network and the cabling back to the closet into the switches, like we said. And the switches, you would need to make sure you have a switch that can power the phones. Not all switches do. You would need to make sure the switch can power the phones and be able to provide power to it, again, through power over Ethernet. The switch itself would need to do that. And this just kind of shows you the structure of how things would be set up. Here's your IP phones going into the power over Ethernet switch and being routed through the IP PBX and gateway and out, etc. One of the other things we might run into is an IDF, intermediate distribution frame. This would be maybe a smaller data closet, or might be a smaller data closet in another building, if you will. But these would typically be the smaller closets that I have on floors of buildings or wings of buildings. Sometimes you hear this called an intermediate distribution frame. These closets, if you will. They called them data closets earlier, equipment rooms. You can also, in some cases, have these be intermediate distribution frames. They're very similar in their structure, if you will. And that's what these are here. And again, this is the kind of thing I would be seeing there. As we get to the work area, I'm going to run into the work area itself, as well as wall outlets or wall jacks. So the work area, this is where many employees would be sitting in a company doing their job. So you would have a desk with, desktop type computer, maybe phone, that kind of stuff. This is their work area. This part of the network. So at the work area, actually right here, this would be the work area here. Here's the work area here. The desk and the computer and the outlet on the wall. So at the work area, we're typically going to have an outlet on the wall to plug into. Old school standard called for at least 2 outlets at the desk, one for voice, one for data. Well, most systems now being IP phone, everything can run over a data outlet. So most times we now have literally 2 data outlets at a work area because they can carry both phone and data, those data outlets. But here's would be the wall jacks, the wall outlets, if you will. Here they are. Again, they're going to be in a couple different forms depending on the need for the facility. If I open that up, what I find inside is literally this type of data jack. This case is a keystone that I actually punch the wires into. The wires are punched into, and this is the horizontal cabling coming from the closet to the outlet. This snaps into the faceplate, allowing the users to plug into. There is different color codes for terminating these. As we do more with cabling in Chapter 5, we'll get into the color code more, but just recognize as you look on the side there is color code there. That lets you know how to terminate it if you're following the A color code or the B color code in your facility. Other items we need to note in our racks, we have racks, KVMs, and rack cooling that we need to mention as we talk about closets. So rack systems, as we said before, we have racks to mount our equipment in. These provide a place for mounting all the equipment in. These come in standard width of 19-inch frames, 19 inches wide, but they do make 23-inch racks. 19 is fairly standard for equipment closet racks. They can be wall mounted or ceiling mounted or freestanding on the floor. And many of these are going to be, in the 6-foot tall ballpark, but they do have different height sizes. And the rack itself is measured or denoted in U's. How many rack units? In other words, how many things can I bolt in there before it is full? Here is a 2-post rack. This would handle most routers and switches kind of thing and patch panels. Here's a 4-post rack that you typically need when you start doing rack mount servers or either large port count switches. Some of your large port count switches need a 4-post rack to mount in there. It needs enough sturdiness, if you will, to mount that equipment in. Here's a ceiling mount rack that can be used. Here's a wall mount rack that can be used. There's a lot of different styles to mount your equipment depending on how much equipment you have in an area. When they say U, they're talking about basically the height of the equipment. Here's kind of a standard router or even a standard switch size of like 1U. Larger, more robust routers or sometimes like 48-port switches or 48-port patch panels start using 2U, meaning 2 U's of space. Well, that seems kind of like, okay, but when I start putting a lot of equipment in the rack, it's going to matter how much space it takes up. And there is actually diagramming software that's going to allow you to kind of predict, is your rack going to get full or do I need 2 racks? And it's all based on that U, how many U's it is. If I buy an equipment rack, here's a 2-post rack. They sell them from 24U to 58U. Again, they come in different sizes. And the more U's you have, the higher it's going to be or taller it's going to be. Again, kind of like the 42U, if you will, is pretty standard. 6-foot tall is pretty standard for equipment racks. Like I said, there is actually diagramming software to allow you to space out and make sure everything is going to fit, or let you know it's not, I need a second rack next to it. And then you can start organizing what goes into what rack, what equipment rack. Other items to note on your equipment rack is a KVM, keyboard, video, and mouse switch. It's not conducive if I have 6 or 7 servers in a rack to have 6 or 7 monitors, one for each server. So what you do is you install, a lot of them come as a little tray. This little monitor and keyboard kind of folds down like a laptop and slides in the rack. And then you slide it out when you need it. And that can be hooked up. That there is, here's the rack closed, here's that slid out and open. Well, this can be set up to hook to multiple servers at one time. And here's one that is set up to connect to, 8 or so servers in the rack. And what happens is that literally has a cable that runs to each one. And then on that KVM switch, you usually use a keystroke sequence to toggle between the different servers. A certain Control Alt 5 or 6 or whatever would allow you to toggle between the servers then. In my racks, I do need to worry about rack cooling, especially if I have a couple rows of racks. I actually have the equipment faced a certain way that I can have cool air come in, hot air leave, and you organize that into rows, if you will, allowing cool air to come into the equipment and hot air being a lot of times blown out the back of the equipment. And then you actually have, if you have a couple rows of, you start organizing the cool rows and the hot rows so that I'm getting cool air in and hot air out of my equipment rooms. You actually design how these things are laid out based on your ventilation, or organize your ventilation based on how you have your things laid out. All right, now we're into cabling. I'm going to pause. On the next podcast, we will dig into the cabling section.